Let's look and see how do we handle when you have resistors in series. If I have this circuit, R1, R2, R3, and so forth. Rn. And I'm trying to find an equivalent. I'm looking for something to replace all these resistors. Is there one resistor I can replace all these with that value? And how would I find that? And to derive that, this is the source here. Notice if I just throw a current, I say, well, since I only have one source labeled minus to plus, that means current going to travel through that source in this direction. And if it travels in that direction, it's going to mark this resistor plus to minus. Ohm's law says V equals R times I. This is R sub 1I. It's going to mark this plus to minus R sub 2I. It's going to mark this plus to minus R sub 3I. That's the voltage. This is plus to minus R sub Ni. So if I do KVL, which is sum of the voltage in a closed loop is 0, I'll have negative Vs plus R1I plus R2I plus R sub 3I, and if you have more, dot, 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 plus R sub Ni equals to 0. Take Vs to the right side, becomes a positive. Factor an I out. What's left here? R1 plus R sub 2 plus R sub 3 Again, my goal was to replace this with a circuit that looks like this. One resistor, I'm going to call it R equivalent, REQ. So what is the value of R equivalent should be? Well, again, if I do KVL here, call this current I, because these are supposed to be equal to each other. This current will equal to this current. This voltage source the same as this voltage source. This resistor is supposed to be the equivalent of these. Well, let's see what the math says here. It says negative Vs plus the voltage drop here, and Ohm's law says V equals I times R. And if you clean this, you have Vs equals I times R equivalent. So for these two equations to be equal to each other, these two equations, Vs is the same Vs, I is the same I. The only way these two will equal to each other if what? If R equivalent equals R1 plus R2 plus R sub 3 plus dot 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 all the way through R sub n. So that's how we find the equivalent resistor when you are having resistors in series.
When they have the same current going through them, right?
Well, when they're in series, they always have the same current. Yep. So our equivalent for resistors in series is this one. Why we care about that? Here's an example. And I'll do the parallel one shortly. If I have this circuit, which is 80 volts, and this is 10 ohm, $30 volts, 7 ohms, 5 ohms, 20 volts and 8 ohms. And the question, what's I? Now what I'm going to do here for this circuit, I'm going to take all the voltage sources, put them next to each other, all the resistors next to each other. So this is my voltage source, the first one, this one. That's the 80. By the way, when you graph it or draw it like this, which side is the positive, which side is the negative? Negative is the small, positive is the big one. So this is really minus to plus. Keep going. This source is labeled which way as you're traveling? Plus to minus, right? So as I'm traveling this way, minus to plus, this is plus to minus. Now let's put the resistors. What do we have? 10, 7, 5, and 8. Now this block has voltage sources in series. We know how to combine them. Either add or subtract. It depends on the direction. Minus to plus. That's 80. Minus to plus. That's the same direction. So do we add or subtract? Add. What's 80 plus 30?
110.
110. This is plus to minus. So what do we do? Subtract. What's 110 minus 20? 90, and it has to be in the direction minus to plus. So these three sources, again, if you did KVL and you go, oh, let me travel this way, minus to plus, plus to minus. These two will be the same sign, and this will be backward to them. Now the resistors, we have 1, 2, 3, 4 resistors. How are they connected?
In series.
So resistors in series, what do you do with them? Add them. 8 and 7, 15 and 5, 20 and 10, 30. This circuit's equal to that. Can we calculate what the current I is? Ohm's law, I equals V over R. V is 90. I is 30. The result is 3 amps. So we have 3 amps going through that circuit.
That's much easier.
Yep, when you can simplify them. Now, what about if the resistors are not in series, maybe in parallel? So let's look at resistors in parallel here. And see what will happen. So I have this circuit. I have a current source pushing current up there, I sub S. I got one resistor of R sub 1, another one R sub 2, and there's more. I'll just go dot, 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 and R sub N. The source pushing current up, the current's going to get to the top, it's going to split and start to come down. There'll be current coming down this way, we're going to call that current I sub 1. There's current coming down this way, we'll call it I sub 2. There's one coming down this way, that's I sub N. If we do KCL at the top, KCL at the top, the current in equals the current out. What is going to that node? Good, I sub S. And what's leaving that node?
I1, I2,
I1, and IN. There's other ones, dot, 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 IN, right? So here we go. Well, we have too many unknowns here. One equation with n unknowns, we can't solve it. So I need to rewrite each one of them maybe in terms of the voltage. Let's call this voltage here Vs, the voltage across the source. So I sub 1 is going to be, it's Vs divided by what? R1. Again, this is coming from V equals I times R, Ohm's law, which means I equals V over R. Now these are connected in parallel, which means they have the same voltage. The voltage is Vs. So this current is Vs over R sub 1. I sub 2 is what? Vs over R sub 2. And I sub n is going to be what? Vs over R sub n. So if you do that substitution, you will have I sub s equals Vs over R sub 1, Vs over R sub 2, Vs over R sub n. If I factor Vs out, 1 over R1 plus 1 over R2 plus 1 over Rn times what? Vs. Again, I'm trying to find an equivalent circuit to that. An equivalent circuit, which means if I put that current source here, I sub s, this is the current I. This is Vs. I'll just call it I instead of I sub 1 here. Now notice the current in, which is what? I sub s equals the current out. And let me write the current out in terms of the voltage and the resistor. So I sub s equals Vs over R equivalent. This voltage divided by that resistor. And again, if these two are equal to each other, that tells me actually, just by looking at the math, 1 over R equivalent has to equal 1 over R1 plus 1 over R2 plus 1 over Rn. That's how we find the equivalent of resistors when they're connected in parallel. That's where the equation came from. Now, if you're decent with math, if you only have 2 resistors, watch the math. If you only have 2 resistors, and you want to find the equivalent of them, right? If you have 2 resistors in parallel, you're looking for the equivalent. They're in parallel. Well, that's the equation I need to use. Here we go. Let me use it. 1 over R equivalent is equal to what? 1 over R sub 1 plus 1 over R sub 2. Now, if I want to add these two, what do I need? Mathematically, what do we need? Common denominator, which is what? R1, R2. These are fractions. I need to multiply R1 by R2 to make it look like this. You multiply the 1 by R2, this will be R2 over R1 R sub 2. To change R sub 2 to R sub 1 times R sub 2, I need to multiply this by R sub 1, multiply the top by R sub 1. So you can say 1 over R equivalent is equal to what? R1 plus R2 over R1 R2. I don't want 1 over R equivalent. I want R equivalent, not 1 over it. Flip this and flip that. Some of you probably heard that when you have two resistors in parallel, somebody said to you, make sure it's the product over the sum. I don't know if you ever heard that or not. That's how you find the equivalent of them. That's a quick way of math. In your head you can do it. Just only for two resistors. Product over the sum. Instead of doing it the other way. If you have more than two, you can't do product over the sum. You got to do two at a time, product over the sum, and just keep doing it. So let me take an example. I don't know, I'll make something up there.
So if it's more than two, then you do the sum over the product?
You do it two at a time. So I'll do it both ways, Nick. Let's say I have this. I don't know, 12. $18. 6. And I'm looking in that direction for R equivalent. What is the value of this? Oh. I can do 1 over R equivalent to be 1 over 12 plus 1 over 18 plus 1 over 6. 1 over R equivalent equals, let me get to my calculator there, 1 divided by 12 plus 1 divided by 18 plus 1 divided by 6. And it says 0.305555. To get R equivalent is going to be what? 1 over that number. One divided by that one, approximately 3.27, repeating 27272727. Now, if I wanted to do them without, not this method, using the product over the sum, you can do two at a time. Doesn't matter which two. So if I grab the last two, this is 18 in parallel with 6. That means parallel. So the value for that, the equivalent of that, the product over the sum. What's 18 plus 6? 24. And the top is what? 18 times 6. I can simplify it while I'm here. By 6, this is 1. By 6, this is what? 4. Right? By 4, I can't. By 2, this is 2. This is 9. 9 over 2, which is what? 4.5?
Yep.
So now my circuit will look like this. Now these two in parallel. Do it again, the product over the sum. 12 in parallel with 4.5. 12 times 4.5 over the sum of them, 12 plus 4.5. That's 16.5. And the top,
24.
24 even?
I think so.
Can't be, that's times 4, no way. 12 times 4.5. 54, you mean. Now let's divide 54 by 16.7. 54 divided by 16.5, I mean that's 7. And look at the answer, 3.27272727. Same answer. So if you get like 4 of them, you do 2 and 2, take the 2 answers, and do it again, if you don't want to use this method.
The other method seems best.
Well, this is nice when you can do the stuff in your head. If you don't have a calculator and you have like numbers you can do in your head. So this is not bad. Your product over the sum, yep, that's 9 over 2. Because you could have went 9 over 2 with a 12 and do this without a calculator. So that's resistors in parallel, resistors in series. Sometimes the problem has a combination of both. It's not just one. You can shoot out and skip anything, yeah. So let me take this example, which looks ugly when you look at it. Six amps. 3 ohms. 9 ohms. Dependent current source of 0.9 I sub 3. 15 ohms split here to 6 and 6. And 4 amps. The question, can you tell me what the power and the voltage of the dependent source? Calculate the power and voltage of the dependent source. The one thing I forgot to tell you, which one's I sub 3. This is I sub 3. This current. And let's call this voltage here Vx.
So 3 and 9.
Is what?
Could you make 3 and 9 one?
Well, I could. The only problem with that, if I combine them, I'm going to lose I sub 3. And this one depends on that current. So once I combine them, I lost that current.
Well, what about 6 and 6?
6 and 6 I can.
And add this series.
Yep, these two in parallel. So if you do the math in your head here, product over the sum. 36 divided by 12, which is what? 3. 3 add to the 15, what are you going to have? 18. So that can be 18. As I said before, it doesn't matter where you move these pieces. I'm going to put the 9 next to it. I'm going to put the dependent source here for now. 0.9 I sub 3, right? That's the 3. This is I sub 3. Wait, let's see. We have a current source going up of 6. We have 1 coming down of 4. Can I combine them into 1? What's the value? 2 going up. Notice that's the current source going up, that's down. You can put them next to each other, up and down, positive and negative. That's a 2. Now I can take these two resistors, combine them into one. It doesn't change I sub 3. Product over the sum. Sum is what? 27? Would that give me a 6? 9 times 18 over 27. By 9, this is 1, that's 3. What's 18 by 3? 6. So now my circuit looks like this. We said 6 here, the last one. And this is I sub 3. Now the circuit becomes a little bit smaller, more manageable. This is Vx. A single node. Now, the top, if I don't count the bottom, the ground. KCL. The current in, what's going in? 2, and let me make sure that I'm going to define this current coming down. We'll call it Ix, because it doesn't have a name. So what's going to that node? 2. What else going to that node? 0.9 I sub 3. This and this going to that node. And what's leaving that node?
V over 3, right?
Well, let's just write this for now. I sub 3 plus what? I sub x. So if you clean that equation, this becomes a negative 0.9. So I'm going to have what? Is it 0.1? I sub 3 plus I sub x. One minus 0.9 is 0.1. Two unknowns in that equation. Can I find what Vx is? Or can I rewrite I sub 3 and I sub x in terms of Vx? I sub 3 is equal to what? It's defined as coming down, so it's the voltage on the top minus the bottom. That's Vx over 3. I sub x, I define it coming down. It's the voltage on the top minus the bottom. That's Vx over 6. So plug them in now, and you only have one unknown. 0.1 times that number. What's 0.1? That's 1/10
So Vx
over 30, right? Plus I sub x, which is Vx over 6. If I don't want to use a calculator, my LCD here is what, 30? What's 2 times 30? 60 equals what? Vx plus 5Vx. Sixty equals 6Vx. Vx equals 10 volts. Beautiful, huh? The question is about the dependent source. Here's my dependent source. It has 0.9 I sub 3. That's the value of it. Well, wait. What was I sub 3? I sub 3 equals Vx over what, 3? Since Vx is 10, that's 10 over 3. 0.9 times that. So this will be 0.9 or 9 over 10. Isn't that what 0.9 is? Times I sub 3, which is what? 10 over 3. So what's the value of that? 3? And I also know the voltage here is what? Vx. Because they're all connected how? In parallel. The voltage here is the same as here, is the same as here, is the same as here. It's all Vx. So I know the voltage through this source, the dependent source. I know the current. So the power, notice we have a current going this way. We have 3 amps going this way. The 3 amp is entering which end of it?
Negative.
The negative. So the power is going to be what? Negative supplied. V times I. 30 watts supplied.